Good morning, everybody. Can you listen to me? Please raise your hand. See, I already logged in at 6:45 only, sir, but because my Sketchbook Pro, see, there is a software here in Viacom through which we teach that was not opening properly. Means yesterday maybe there was not proper shutdown, so I need to reinstall that software, and that created a late delay. So I'm again repeating, I'm sorry, there is a delay from my side as the Sketchbook Pro did not open properly. But everyone is there. Still some students need to join. See, yesterday one student was asking, sir, this is for which batch? I did talk to schedule manager. This is for all the students, including GM, GE, etc., whoever has been informed, because it is the last round going on network, sir. Please understand this. For GATE 2022, Viacom, this is the last batch because there is no time. Even other subjects need to be completed. So all the students who are GM or whatever it is, please make sure that you are available. That is the reason Seshu told only to go 3 hours a day. So now this 20 minutes delay I will cover, sir. Everyone, please, can you listen to me? Please raise your hand. Yes, I will be going with the revision first, and slowly I will pick up what to be done today. I want everyone, see, there is a problem with the software, that Sketchbook Pro, the software where I need to write on this laptop tool is not working. There may be an issue yesterday regarding its shutdown, so I reinstalled the software, and that is the reason it took time, because morning I need to open it, give separate file name, but it was not opening. That is a problem. Chalo, these are the technical glitches we face, sir. Today online coaching, that is a problem also. Laptops go very slow after loading so many softwares. They get stuck up in between, power fluctuations. In my side also, sir, power, though we have inverter, but still there is a power fluctuation sometimes that restarts the laptop or the screen of the Viacom, etc. So everyone, I'm back here. Myself, see, I turned off video purposefully. I will turn it on later because now speed of internet also need to pick up in my side. So everybody, good morning. This is day 2. Yes, this is day 2 of network theory or electrical circuit analysis, common for all the batches. And this is the last round that is going on. Now in this regard, everybody should please understand this. Yes. So quick review what we did yesterday. I want everyone to listen carefully again. Okay, everybody please listen. Yeah, good morning everybody, sir. Yeah, one student told don't delay extend after 10:30. That is true, sir. I will not do that. Yes. Anonymous attendee. Yes, 10:30 I will stop, sir. Okay, no problem. That I will accept because today delay is my side. I will not extend beyond 10:30. I accept that. Okay, I accept that. Pakka. Chalo. Now listen everyone. See, I told now revision, sir. Every day I will do revision of 5 minutes. What happened yesterday? I want everyone to listen here. Okay. So now see, I told this subject is one of the major subject in GATE, IES, GENCO, TRANSCO, in most of the competitive exams where electrical engineer works. This subject is a highly dominant. The average marks is 10. The range is from 8 to 12, and it can go sometimes up to 14, even 17 marks. It happens, sir. And in IES, UPSC, and other exams, also 10% of the marks and 10% of the questions come from network theory or circuit analysis only. Then in ESC mains, 84 marks out of 300 in paper 1 conventional. Okay. Then I told the secret mantra how to get rank, sir. See, simple. In my subject also, how to get rank. First, read our notes, sir. Revise a lot of times. You need to remember all the models. Second step, do IES bits of both EEE and EE, electronics and telecommunication, because IES bits are more theoretical, formula based. Then go to GATE bits, sir. Okay, then write a lot of exams and practice. And with these exams only, you do correction, feedback, and lot of clarity will come in the subject. Keep writing exams, sir. It won't come in one day. Don't worry also. Initially, you don't get full marks. Don't worry, sir. It's a time process. Okay, not every student, is capable to crack just like that. You take time, but learn, practice, revise. You will get it automatically after several attempts. Now, sir, you will get to the top level. Then IES conventional people, I told one solved examples you do, one book solved examples completely you do, and also previous conventional paper. That is for students who clear prelims only. Plus, apart from that, please, sir, solve this paper. Suppose you are attempting GENCO, TRANSCO exam, JTO exam. Please buy these books, sir. All these solved papers are there with ACE Academy, ACE Engineering Publications. You please buy this hardly 300 rupees, 200 rupees, these books are, sir. But you will not get so many papers anywhere in the world. See, when I wrote GATE in 2003, na, sir, there was no such material available in India, sir. But these institutions like ACE Academy have collected all the papers for the last 30, 40 years and they are publishing with solutions which are 100% accurate. The good thing in ACE Academy, what I find is the solutions are very accurate, sir. Today I am writing solutions. Previously, my gurus, my teachers wrote, and they are highly accurate, sir. That is a guarantee I can give. Sir, what is so special about ACE Engineering Academy is our solutions are highly accurate, detailed explanation. You check it, sir. Other publications also you check it. They are not so accurate and no detailed explanation. But we insist on detailed explanation and accuracy. So any student attempting such exams, please subscribe these papers. These books are available in our ACE publications. You can purchase online, okay, and give your address. They will courier you. Then my reference books are, one is Fundamentals of Electric Circuit by Alexander and Sadhguru. One is Engineering Circuit Analysis by Haight and Kimmerly. One is a EEE author. Second is a EC author. Both together is an ultimate combination, sir. I'm telling they are ultimate combination. Okay, then my subject is divided into 3 parts. Part 1 is DC circuit analysis. So we do analysis for ideal DC. Ideal DC signal is a very rare signal, but it is available in a newly purchased battery as well as precision voltage regulators in electronics, where dV by dt and di by dt are zeros. When these are zero, na sir, resistor works normally, but inductor acts like short circuit in steady state and capacitor acts as open circuit in steady state. Then basics of time variance. Basics of time variance. See, this chapter is a small chapter, but in this chapter, I will introduce how inductor and capacitor will be working and analysis through Ohm's law. Resistor is still homogeneous proportional. What does it mean? Triangular voltage will give triangular current. Square voltage will give square current. Sawtooth voltage will give sawtooth current. That is still normal. Okay, but inductor and capacitor, na sir, they start working. How to analyze them fundamentally, that I will teach. So chapter 4 is a small chapter, that is basics of time variance we call. That is called basics of time variance. Okay, na? So that we will introduce. Then we will come to AC steady state. This is also one of the number one waveform in power level. See, number one waveform at signal level is DC, sir. Number one waveform at power level is AC. That is why we have got 2 steady state analysis. One is DC steady state analysis and one is AC steady state analysis. But of course, AC steady state analysis means which AC? Sinusoidal AC. Okay, na? Then for that phasor analysis we do. Here again, resistor is normal, homogeneous proportional, and it is in phase element. That means in resistor, current is in phase with voltage, but inductor is a lagging where current lags voltage by 90, and in capacitor, current leads voltage by 90. Then in transient circuit analysis, yes, that is a third part where dynamic response. Okay, where it is starting, how it is starting, what is initial condition, what is the order of the circuit, what is the stability of the network, all such things we learn. So generally in electrical engineering, whether it is a power system network or machine network or any network, see, we have ideal DC steady state if it is DC input, ideal AC steady state which is sinusoidal input, and dynamic response for these inputs that we learn. That are the 3 parts. But when you go to signals and systems and power electronics, na sir, you have more complex waveforms. That is why mathematical analysis is more in such subjects. Then we have miscellaneous topics also. Yes, we have miscellaneous topics also. Okay, that is topology, 2 ports, locus, duals, all we will study, sir. Then what is the importance of electrical energy? Yes, electrical energy is superior and dominant because of 2 reasons. One is interconvertibility and second is transportation. What is interconvertibility? Interconvertibility is a process where we can convert different forms of energy into electrical and we can convert them back. That is what we are doing. There is a flexibility and beauty of electrical engineering, sir, and electrical energy. Heat energy to electrical, mechanical, solar, wind, chemical, all you can convert into electrical and you can convert them back. So there is a wonderful flexible energy available in the world. Then another beautiful reason why this is number one energy is we can generate and transport this energy anywhere in the world in bulk quantities and longer distances and in the most economical way. The only requirement is we require a transmission network. We require a transmission network, that is our electrical circuits and networks only. Example, why it is economical, our 1 unit of electrical energy, in our house, our energy meter is there, sir. Energy meter 1 unit means what? 1 kilowatt hour. What is the meaning of 1 kilowatt hour? 1000 watts consumed for 1 hour. And it is hardly rupees 3 per unit. It is hardly rupees 3 per unit. Then electrical energy, yes, electrical energy we learn both at power level and signal level. Power level is high voltage, high current, high power, but frequency is 50. Signal level, low voltage, low current, low power, but frequencies are very high in communication and signal processing. Like air conditioner, if you buy, is a power level product. There what we look efficiency, power factor, safety, reliability, cost, percentage, regulation, losses. But if you buy a cell phone, that is a signal level product. That also work with electrical energy, but it is a signal power communication product. Yes or no? There we look into precision, accuracy, speed, compact, portable, automation, intelligence. That is why when you buy a cell phone, there we are not looking into efficiency and power factor. In cell phone, what we look, sir? Speed, how much RAM is there, how much screen clarity is there, how much intelligent is Google Assistant available, Siri available in iPhone, such things we see. But if you buy air conditioner, star rating we see. That star rating is about how much power factor, inbuilt voltage regulator, etc. So that is the difference you should know. We learn both, sir. Both are important. Both are important. Don't say, sir, I learn only power level or signal level. Please don't say that. That is why our branch is called Electrical and Electronics Engineering. Today, electrical engineering alone cannot work, sir. Today, everything is automation, na, sir. Though I know induction motor is there in air conditioner, but that is microcontroller controlled, na, sir. So we should learn. So some subjects are power level subjects like power system, machines, power electronics. Some subjects are signal level like microprocessor, analog, digital, signals and system. And networks, controls, measurements are common subjects. Okay. Now, what is the problem with electrical energy? Yes, some students say, some parents ask me, sir, electrical engineering is tough. They ask, sir. I say yes. Yes, electrical engineering is tough, understandable. Okay, and the reason is our senses don't support, our body senses don't support in understanding these parameters like electrical voltage, electrical current, electrical flux. You cannot understand because our senses are not supporting, sir. Then how to learn? We learn electrical engineering by using notations and maths. What are notations? Notations are the rules developed by our great engineers and scientists, which are based on mathematical proof. So we follow notations and respect lot of maths. So if you're a good mathematician, sir, Laplace transform, Fourier series, Fourier transform, Z transforms, matrices, algebra, differential equations, you are number one electrical engineer. So I suggest everyone who want to get first rank, you should be very good in maths, sir. Maths and its applications to electrical, not just maths. See, intermediate maths, even I got full marks, sir. 75 out of 75, 100 out of 100. That is not applications, sir. Engineering maths is about applications. So please, everybody, be good in engineering maths and its applications. Okay. Then follow notations. What are notations? Like rules, mesh analysis rules I will teach, nodal analysis rules I will see. What is ideal op amp? What is ideal diode? Like that we follow rules, na, sir. That are rules. Like notations. What are notations? Example, taking polarity for voltage, direction for current is also notation. Okay, current leaving positive terminal is called source, power delivered positive. Current entering positive terminal is the sink, power absorbed is positive. Then you take an example of permanent magnet. Okay, then you take an example of permanent magnet. Okay, now in a permanent magnet, yes, flux leaves. In a permanent magnet, flux leaves. Okay, the cross-sectional area of the surface, that pole is called north pole, and externally flux enters the surface of the pole is called south pole. Okay, in any surface, if flux leaves the surface, it's called north pole, and flux enters the surface, it is called south pole. Internally, they go from south to north. Internally, they go from south to north. Okay, that is the meaning here. Okay, that is the meaning. Okay, so yes, permanent magnet. That is also a notation. That means taking polarity, taking direction, flux orientation. All these are notations, na, sir, because in electrical engineering, we cannot see them, we cannot touch them, we cannot taste them. Then another example is following like Ampere right hand thumb rule. That is also a very powerful notation given by Ampere. Okay, if a straight current carrying conductor is indicated by thumb, the closed fingers indicate the orientation of flux, but right hand only, sir. That is what hand? Right hand only. Okay, na? Then now circuit or network model. Now, what is RLC? Electrical engineering is all about analysis with RLC components, but what they represent? Resistor represents the linear time invariant property of matter. Inductor represents electromagnetic property of matter. Capacitor represents electrostatic property of matter. Example, like our power system transmission line is there. Now, based on length, we call them as short line, medium line, long line. Likewise, our ACSR conductors have a lot of resistance. Okay, then there is a flux linkage internally, externally, there is inductance, and charged conductor with respect to ground also has capacitance. So that is why it is an RLC model. But what LNC represents? Electromagnetic property and electrostatic property. Now these components need not be physical, sir. Okay, these are properties. Don't always misunderstand RLC means component. RLC are the properties. We model them as components and learn. Okay, now? Like in our fan, you can see physical capacitor. Yes or no, in your house, fan is there, na sir. Their capacitor is visible. But in transmission line, where is capacitor? It is a property. It is a distributed parameter. It is not located at one place. Okay, na? So capacitance represents electrostatic property. A charged conductor with respect to ground. A charged conductor with respect to ground. Okay, exhibits capacitance property like that. Okay, na? Then now this is a good example of understanding notations. Capacitor represents electrostatic property. So wherever it is there, model it, like in transmission line, like in diode, like in power factor correction, we model capacitor. Capacitor symbol and capacitor passive notation. What is passive notation? Here current enters positive. That is a notation. That is why it is called notation. Now how to learn these capacitor problems mathematically by Ohm's law, for example. Like Ohm's law for capacitor is I is C dV by dt. Okay, we will derive them, sir. First, we will derive them. Today, all basics will come. But this I is C dV by dt. Now, from this equation, I will teach everything. Like for ideal DC, yes, capacitor acts as open circuit. For ideal AC sinusoid, current leads voltage by 90 degrees in phase. Okay, so that is how we learn. Capacitor for ideal AC acts as open circuit, and capacitor for ideal AC current leads voltage. Like that we learn. Okay, now. So that is how mathematically we are learning, sir. Physically, it is not easy to explain. But for example, physically what is really happening in capacitor, current never flow, but it works through the principle of polarization. Now in capacitor, there is a dielectric material. Dielectrics are very special insulators which can exhibit polarization. Like mica, resin, oil, glass, electrolytes, weak acids, they can have dipoles. So when you give voltage polarity based on the orientation of electric field, the dipoles align, and that is how the charge gets accumulated on the plates. Now, when you give reverse voltage, yes, when you give reverse voltage, the electric field also reverses and the polarity changes. That is how for given voltage polarity, the charge gets accumulated, but physical current is never flowing through capacitor. That is the meaning. So physical current is never flowing, but only due to polarization, the charge gets accumulated. Okay, that is how this current in capacitor is called what current? Displacement current. Displacement current. Okay, this topic you can search in internet or in EMF, they explain the derivations, sir. But normal wire conductor, that current is called conventional current where physical charge transfers. So in our normal wires, physical charge transfer, so current is rate of flow of charge. That is our normal wire. But in capacitor, we should not say. The actual current is called displacement current. That is due to polarization of the material. Okay, na? So that is the meaning. So physically explanation is different, but how we are learning mathematically, that is important. So though physically, that is very interesting phenomena, polarization, but how I am teaching mathematically, that is how electrical engineering is simple to learn mathematically. That is my argument. So based on this, I wrote that. Yes, based on this, I wrote that. Yes, engineering is application of science and analysis with mathematical modeling. That is why engineering is application of science. And let us analyze mathematically. Now I started first definition, circuit versus network. Circuits and networks are interconnection of various elements to act together. But in a circuit, current is intended to flow through all the elements. But in a network, it is not necessary that current should flow through all the elements. But what are the conditions for current to flow? Yes, the conditions for current to flow is first, there should be a driving force or voltage. Second, there should be closed path. Okay, driving force or voltage. Second, there should be closed path. Then, yes, then everybody. Okay, now after that, I gave some examples. All our practical big interconnected systems are networks only, but we do circuit analysis in those parts where current is flowing. Circuits are building blocks of networks. Okay, circuits are building blocks of networks. Okay, then our power system is a big network, but a motor running in it is a circuit at power level. Similarly, our communication system is a big network. Okay, but a transmitter working in it is a circuit at signal level. That is the difference. Now in your house also it is a network because everything is not turned on. If you guarantee that everything is turned on your house, then it is a circuit. But otherwise, practical big systems are always networks. Okay, then electrical people study more power analysis where closed path concepts are included as energy to be transmitted through a wire. So in electrical engineering, bulk energy has to be transported through interconnection and wires, and hence, yes, circuit concepts we learn a lot. So we learn what? Circuit concepts. But for EC students, At signal level communication, wireless communication, etc., physical connection is not necessary. So they learn more network concepts like Wi-Fi, Bluetooth, mobile, etc. Like in your cell phone, you say is network there in your phone, but you will never say is circuit there in your phone, because Airtel is a network, Vodafone is a network, Wi-Fi, Bluetooth are network concepts. So ECE people, they learn network concepts where energy at small level is transported without physical connection, but electrical people on the other hand, they transport energy at power level through physical connection and circuit concepts they learn. That is a big difference. Then what are network components or elements? That is the second definition. What are network components or elements? See, I told don't disturb me by raising your hand. Some students are raising their hand, right? Priyanka Devi, Pallavi, Chaitanya. I told that after 10:30, ask any doubt, sir. Keep writing. See, one way what you do is everyone take one pen, paper, pad, and keep writing doubts, even silly doubt or whatever I say. Maybe sometimes I pronounce mistake, etc. You write on paper, sir. And 10:30, ask me. So give me slide number, sir. In this so and so slide, I am having doubt. Please explain again. Please, sir, understand. Because in a virtual platform, I cannot do like everyone, sir. It is not possible. So Vaishnavi Tejawat, please put down your hand, please. Okay. So please understand. Everyone, please cooperate. I understand. See, sometimes maybe I also pronounce wrong. But what to do, sir? If it is a physical classroom, I can see the intention of the student physically and I can adjust myself. But here it is not possible, sir. So what you do, even a silly doubt or wrong doubt or anything, na, sir, please note down. And 10:30, ask me, sir, please. That is a request. Okay, please understand. Because here I tried initially to take individual doubts, but that is killing the time. Okay, please understand. Please cooperate. Okay, chalo. Now, sir, what are network components or elements? Okay, now all our applications in electrical engineering are our components. But when these applications are mathematically modeled as a circuit or network, we use fundamental network components to model them. Okay, that is very interesting. Now, what does it mean, sir? What does it mean? You see, the meaning is very simple. Like, I want to learn about a motor. Motor is an application in electrical engineering, which converts electrical energy to mechanical. But to understand motor, I need to build its network model. Equivalent circuits we learn, sir. Transformer equivalent circuit, DC machine equivalent circuit, inductor motor equivalent circuit, like that. Power system I want to learn. Power system also single line diagram. We do network analysis, na, sir. Okay, fault analysis, zero sequence network, positive sequence network. This is all network analysis only, sir. So that is what is electrical engineering. Anything in the world we model into circuit or network, and in that we use fundamental network components like voltage source, current source, resistor, inductor, capacitor to model them. Example, heater converts electrical to heat, but we model heater as a resistor and we give energy and find power absorbed. Then fan is a single phase induction motor. Okay, it has got main winding, auxiliary winding, capacitor to start and switch. There we give AC voltage and AC current and we analyze. Okay, that is what we do physically. Okay, similarly, a BJT is a device actually. A BJT is a semiconductor device, na, sir. But how we are learning BJT? It has got its equivalent circuit. I am giving approximate, sir. This is not accurate. EDC analog, sir, will give the accurate. I don't know that subject answer, but concept I'm telling. A BJT also has an equivalent circuit, which is a current dependent current source. And beta is the gain. Na? Here beta. This beta is the gain, current gain. So like that, I will model a BJT. This comes from physical explanation and principle of operation. But with that, I will teach you how BJT works as amplifier, oscillator, etc. That is the meaning. So everything in the world, we model into networks and learn. Then what are linear components? So though everything in the world is non-linear, but we can make them linear by operating for small incremental changes, But the same system for big sudden changes undergoes non-linear mode of operation. Okay, the same thing for big sudden changes undergoes non-linear. Like, see, left side is a linear function, right side is a non-linear function. Linear functions are homogeneous and proportional. Right side function is non-linear and non-homogeneous. That is why they are unpredictable. Linear functions are predictable and they can be modeled in max. Non-linear functions, you cannot model them in max accurately. Okay, though everything in the world is non-linear, but how to make it linear? Now, this is the concept. Like this green line is a non-linear function. Both I am writing 2 times. Same function I am writing 2 times. Why it is non-linear? See, initially increasing, then decreasing. proportionality failed. Here also initially increasing then decreasing, proportionality failed. That is why both are nonlinear functions only. But here that nonlinear function, if you analyze for small incremental changes, that function can be modeled as a straight line linear. But the same function, if you analyze for long or big sudden change, is nonlinear mode of operation. So though everything in the world is nonlinear, for all small incremental changes linear, but big sudden changes nonlinear, like that. Okay, so every electrical component has ratings or specifications. So as long as you operate them within the ratings, they are said to be linear. Simple meaning. So as long as they obey Ohm's law, Kirchhoff law, etc., they are said to be linear. Okay, now diode is originally nonlinear, no doubt. But how we are able to do circuit analysis to diode? Because we do small signal analysis. We do operate them within the ratings. Like you select a diode, if it is a 30 volt clipper, 30 volt clamper, like that you select, and there we do analysis. So though diode is originally nonlinear, but we operate them in small signal analysis mode within the specifications, and in that range it is called linear. That is why a diode is represented as a linear resistor in that range only, So in electrical circuit analysis, if every component obeys, okay, Ohm's law, Kirchhoff law, Faraday's law, etc., and they are designed and operated within the ratings, they are said to be linear. Okay, then bilateral. If the component properties are independent to circuit condition, okay, whether voltage is coming up positive, down positive, current is going left, right, independent, the behavior of component is unique. Such components are called bilateral. They are very easy components. What are unilateral? Such components properties depends upon circuit condition, like forward bias, reverse bias, state of operation. Okay, what are the quadrants of operation? So such things whose properties and characteristics depends upon circuit condition, they are called unilateral. Like diode is a unilateral. Yes, diode is a unilateral because its state depend upon the voltage polarity you apply. But resistor state is unique, independent to the voltage polarity. But diode state depends upon the voltage polarity. Okay, so that is why these are unilateral devices, but resistor is a bilateral device. Then based on the static VI characteristics, yes, based on the static VI characteristics, yes, if first quadrant and third quadrant characteristics are symmetrical, if first quadrant and third quadrant's characteristics are symmetrical, then they are bilateral. But if first quadrant is not equal to third quadrant, then it is asymmetrical. So if first quadrant and third quadrants are symmetrical or mirror images, they are bilateral. But if first quadrant is not equal to third quadrant, they are asymmetrical unilateral. Okay, that is the meaning there. That is a mathematical way. So I gave examples like resistor is linear because they obey homogeneity or proportionality, and they are bilateral because first quadrant and third quadrants are symmetrical mirror image. But diode is not, because they are not mirror image. So diode is a unilateral device and resistor is a bilateral device. Okay, so RLC components are bilateral and diode, transistor, MOSFET, thyristor are unilateral. Then I ask this example question. What about TRIAC and SCR? SCR is a unilateral switch. It is a DC switch, but TRIAC is an AC switch. It can work in both quadrants symmetrically. But if you take two SCRs in anti-parallel, then it becomes bilateral switch. But right now, SCR, a single SCR is a DC switch, which will work and conduct only in one direction. But a TRIAC is a bilateral switch or AC switch. It can conduct and block both sides. Okay, that is a big difference between SCR and a TRIAC. Then active versus passive elements. What are active elements? Active elements drive energy. Okay, deliver energy externally. Generally, voltage and current sources are active. But what is the notation to follow? If it is an active element, current leaves the positive terminal of voltage. Current leaves the positive terminal of voltage. It is called as a source. Power delivered is positive. Power absorbed is negative. There is a meaning there. Then what are passive elements or sink? Passive elements are sink. Yes. These elements absorb, dissipate, or convert energy, okay, in different forms. Okay, like RLC elements are passive. Resistor dissipate electrical energy in heat. Inductor store in electromagnetic form. Capacitor store in electrostatic form. Then notation for sink, the direction in which current enter is positive. Sink absorbs, so power absorbed is positive. But if someone asks what is the power delivered, it is a wrong question. We should put negative. Then based on static or steady state VI characteristics, first quadrant and third quadrant belong to sink, and second and fourth belong to source. Okay, na? Then I gave some example. A rechargeable battery is the best example. While discharging, normally it is a source mode. In fourth quadrant, I will represent. While charging, current as reversed, it is a sink concept. Voltage is almost same. Okay, neglecting voltage regulation, voltage is almost same. Then synchronous machines. Yes, synchronous machine. Example, here first quadrant represents motor, which converts electrical to mechanical. It is a sink of electrical system. Second quadrant is generator, where it is a source of electrical system. So that is the meaning, sir. What is the meaning of these quadrants? I am giving two examples, like rechargeable battery example, synchronous machine, circle diagram example. Okay, na? Then I gave gate question, like what is this component? It is non-linear because saturation is coming. Okay, and it is passive because it is behaving in first and third, and it is bilateral because they are mirror images. Yes, it is bilateral because it is mirror image. Okay, na? Yes, it is bilateral because it is mirror image. Then this is also non-linear. Yes, this is also non-linear because it is not homogeneous. It is parabolic, sir, not proportional. Actually, it is both passive and active. If that option is give, ticket. But here, actually in exam, we did not give. So next best option we have to go. What is the next best option? See, passive elements can never become active, but active elements can become passive. Like resistor can never generate, but battery can be charged. So globally active. And there is no mirror image between 1 and 3 and 2 and 4. So it is a unilateral. So answer is non-linear, active, unilateral. Then here also, left side, it is a non-linear, active, bilateral. And right side is non-linear, okay, active, globally active, and unilateral. Okay, now I am writing the important things are now conclusions. Yesterday's topic, some important conclusions I'm writing. Okay, now I'm writing some important conclusions. Okay, I want everyone to follow. So after writing, now clear examples I will take. Okay, now I want to write certain examples. Okay, now I'm writing a note. I'm continuing from here. Everybody please follow. Okay, sir, today some time we lost, no problem. We will pick it up slowly. Don't worry. Sure, now see here. Now first part I want to write is a transistor BJT is globally passive. Okay, transistor BJT is globally passive, but locally as an amplifier. Okay, locally as an amplifier is said to be active. Please understand. I will tell you the meaning. A transistor BJT is globally passive, but locally as an amplifier is said to be active. Then most of semiconductor devices, okay, when biased, okay, with internal voltage drops, okay, I can say cut-in voltages or voltage drops, and reverse leakage currents. Okay, minority charges are reverse leakage current. Yes, reverse leakage current are said to be active. I will tell you the meaning again. Okay, similarly, inductors and capacitors are globally passive. Okay, inductors and capacitors are globally passive, but locally during transients, when they release energy, are said to be active. Okay, now inductors, capacitors are globally passive, but during transients when they release energy are said to be active. Even op-amp. See, op-amp. Okay, now op-amp is globally non-linear. Okay, non-linear, but yeah, locally below saturation, okay, is said to be linear, Chalo, now everyone read these 4 points. I will explain now. Everyone read these 4 points. I'm giving 1 minute. Read this now. Okay, now see the meaning, sir. I will explain. Everybody listen, sir. See, BJT. Now we know, sir, BJT is like this NPN transistor. Okay, actually, this is a passive, it is not generating any energy. BJT is passive globally. But, sir, in analog, one of its application is amplifier. What we do, we bias it. Okay, you know what is biasing, na, sir? Okay, we bias it by giving proper registers. Okay, ground it, common emitter mode. Then we do VCC here, VCC here, so that the operating point Q come in which mode? Active region. See, in BJT, there are three regions. Cutoff means off, saturation means on, and active region. So once we bias the device into active region, then I can say a small base signal become large collector signal. That is the meaning. So BJT alone is a passive element, sir. But when you bias it and operate in active region, then a small signal is amplified into large signal. This mode is called active mode or active operation. That is why BJT is passive only. It is not a generator. But as an amplifier, we say active. That is why in analog, yours are always say BJT is an active element. Why? Because most of the time he is operating like an amplifier or oscillator. So such concepts are called active regions or active devices. Otherwise, BJT alone is a passive element only. But when you bias it and operate, okay, then it is called active. Okay, na? That is the difference. Similarly, semiconductor device. See, suppose you take a diode. Most of the semiconductor device have cut-in voltage. Okay, na? Like in silicon, it is 0.7, germanium 0.3. Okay, plus reverse leakage currents will come. Minority charges go ulta, reverse leakage current. So when you consider this biased voltage and reverse leakage current, it is like current leaving positive terminal. Current leaving positive terminal, it is source mode. That is active mode. This is also active. That is why, yes, most of the semiconductor devices when biased, okay, with internal cut-in voltages and leakage currents are said to be active. Then, sir, what about inductors, capacitors? See, inductors, capacitors are globally passive. Okay, inductors and capacitors are globally passive. Actually, inductor stores energy. See, inductor stores energy in electromagnetic form, capacitor stores in static. But during transients, when they release energy, see, sometimes they release energy externally, they release energy. That mode is called active. With initial conditions, we will do such problems, sir. Source-free first-order circuits, source-free second-order circuits when we study. There I will prove that at that time, when inductors and capacitors are releasing energy, they are called active devices. Otherwise, inductors, capacitors are globally passive. But when they release energy, then they are called active. Then op-amp. See, op-amp is non-linear, sir. It is a very complex semiconductor device. But if you operate them within the saturation or below saturation, then it is said to be linear. Even transformer also, na, sir. Transformer BH curve is a non-linear curve. Transformer hysteresis curve. Yes or no, everybody? Transformer hysteresis curve or BH curve is a non-linear. But if you operate the transformer below saturation, it's said to be linear. Like that, op-amp is also non-linear, but if you operate below the saturation, it's said to be linear. That is why we call op-amp as a linear LDIC, linear, okay, and digital IC applications we learn like that. So that is the meaning, sir. So these 4 points are the 4 clarity points that you should know why we call them as that. Originally non-linear only, but as a linear device within the saturation, we do operation. Okay, now that is the meaning. Now I'm continuing further. Yes, another important classification is lumped parameters. Now listen carefully. Lumped parameters. Okay, lumped parameters. What is called lumped? Okay. Now, suppose there is a wire of, let us say, 1 kilometer length. There is a long wire of 1 kilometer length. Now, can I say the resistance of the wire in the left corner or middle or right corner? No, actually resistance is a function of length. Resistance is a function of area. Resistance is a function of temperature. But if I model the entire resistance, at one spot, okay, if I model the entire resistance at one spot as a point form or group form, okay, if this model the entire resistance as a point form or group form, where we neglect, okay, yes, parametric changes, parametric changes like length, okay, yes, like length, area, okay, temperature, shape, okay, etc. are said to be lumped models. So actually, resistance is a complex parameter, sir. It depends upon length, area, temperature, shape, many things. But what is called lumped modeling? If I model the resistance as a constant, independent to those changes, actually it is impossible to do like this. But if you model the components independent to those changes like length, area, temperature, shape, etc., such models are called lumped models. Okay, lumped models are simplified models where parametric changes are not involved. I will assume, that means in my subject when I'm doing a problem, I will assume length is fixed. I will assume area is uniform. Okay, na? I will assume the charge density is uniform, like that. Okay, na? I will assume temperature is uniform. Such assumptions, if you take and parametric changes are not considered, such models are called lumped models. What are the best examples? See example 1. Now, PCB components. Yes, PCB components. Yes, PCB components are best example of lumped because PCB components are very small and compact, na sir. Their parametric changes we don't take. We assume temperature is uniform, area is fixed, length is fixed at a point form. So no changes are considered while doing analysis. Another best example is, see, a DC machine, armature of a DC machine. Now this is the best example. Now this is armature of a DC machine. Now this is armature resistance. Let us say it is 1 ohm. Actually, armature resistance is a very complex winding, sir. Armature resistance is a very complex winding inside the motor. Yes or no? Armature resistance is a very complex winding inside the motor. But if I represent the entire winding externally here, in lumped form, where I neglect all these changes, such model is called lumped model. Physically, can you really separate resistance out of the armature? Impossible, no, sir. But we model like this as a constant, where lap winding, wave winding, multiple paths, though everything is there, I don't consider those changes. I'll model as a constant. Such model is lumped. Now, best example is this, sir. This is the best example. Like model of medium distance transmission lines as T and pi network. See, T and also pi networks. T or pi networks. Okay, T or pi networks. There is another better model I can say. See, in T model here Z by 2, Y we take. In pi model Z, Y by 2 we take. Okay, na? So, what is the meaning? See, what is the meaning here? Everybody, please understand this. So, model of medium distance transmission lines. See, actually, suppose a transmission line coming from Hyderabad to Okay, Sangareddy. Suppose I stay in Hyderabad to Sangareddy, some 60 kilometers. 60 kilometers means short line. Okay, or from Hyderabad to Sholapur. But sir, these lines you cannot actually, resistance is different at different parts. Temperature can be different places. Okay, but if you model them as constants by considering at point form, such models are called what models? Lumped models. So actually, resistance is a complex model like inductance, capacitance. So many things in the world are very tough to model, sir. But if I model these parameters where we neglect parametric changes, such models are called what models? Lumped models, simplified models. Okay, easy models. Okay, so first we do lumped models. Now, what are the advantages and disadvantages of lumped models? What are the advantages? See, lumped parameters. Okay, lumped parameters are, first point is easy to represent. Easy to represent. Okay, easy to represent. Then we use solution is easy because simple maths is important. Simple mathematics. We use simple maths to solve lumped models like linear algebra, okay, linear algebra, matrices, etc. Okay, that is easy. Then solutions are faster. Solutions are faster because they are easy enough. Solutions are faster. But yes, but approximate solution will come. There is a problem in lumped models. So one way easy to represent. Yes, one way easy to represent. No doubt. One way simple max. Okay. Solutions are deadly faster, but approximate answers are. So one way lumped models are easy to learn, easy to understand mathematically, faster solutions, but answers are not 100% accurate. Answers are approximate. That is a big difference you should know. Okay. Now, what are distributed parameters? Yes, what are distributed parameters? Okay, na? What are distributed parameters? Okay. Yes. Now, the same wire of length 1 kilometer I am taking. Okay. This is the starting point O. This is point A, and this is point B. Okay. Now, O to A length L1. Okay. O to B length L2. O to B length L2. Now we know actually R is rho L by A ohms. That means actually resistance is a proportional function of length. Yes or no? In the previous case, what I did, sir, in the previous case, though resistance is a function of length, I did not consider the parametric change. I consider the length is fixed, everything is constant. But here, how I am modeling? Here, though resistance is a function of length, I am now calculating at different points as a function of length, where R actual is dou R by dou L. What is the meaning? That means I'm modeling that resistance is a function of length or resistance will vary with length. So this, in this case, what we took, we consider in distributed model, we consider parametric. Yes, we consider parametric changes. We consider parametric changes. Okay, and model the components accurately and model the components accurately like here I took example length, then later temperature you can change, and accordingly you say array O to A segment temperature is different, A to B segment temperature is different, then like that I will model. So if we consider parametric changes and model, such models are called distributed models. Okay, that parametric changes can be length, area, material, temperature, shape, etc. Such models are called what, sir? Such models are called what models? They are distributed models. They are called what models, sir? Distributed models. Okay, na? Now, the best examples are model of long distance transmission lines. Okay, model of long distance transmission line using rigorous solution. Okay, now using rigorous solution. Okay, then another example is EMF concepts. Okay, EMF concepts. Okay, then I can give examples like, okay, waveguide principles. Okay, Then I can give sonar radar examples, antenna examples, antenna modeling. Okay. Antenna models are very complex models. What they mean, sir? See, in long line, I'll give you an example, sir. See, here in lumped models, short, medium line, I gave example, sir. Here, medium line, we lump the parameter at one spot and learn, sir. Okay. In medium line, we lump the parameter at one spot and learn. Okay, now we lump the parameter at one spot and learn. We assume them as constants. We assume them as constants. So that is why in ABCD parameters of medium line, short line are constants. But here what happens, if you take long line, ABCD parameters are function of characteristic impedance and propagation constant, sir. Like ZC cos H gamma L, 1 by ZC sin H gamma L. That means they are distributed models. So long line is where accuracy is more, very complex. But yes, where ABCD parameters are function of characteristic impedance and yes, propagation constant. But here what we are taking, their constant is fixed. Here they are varying. So that accuracy is coming here. And field theory, sir. In field theory also, permeability changes, permittivity changes, temperature changes, flux density changes, all these changes we take. In EMF also, all changes we take. Okay, I will take all changes in vector analysis and I will do antenna models, etc. They are very complex. Now, what is the advantage of disadvantage? In distributed models, okay, in distributed models, yes, now listen, in distributed models, okay, they are complex to represent. Yes, complex to represent. Okay, now complex to represent. That is the first thing. They are complex to represent. Then we use advanced mathematics to solve them. Advanced maths like differential equation, vector calculus, okay, transform theory, etc. So that is why they are very tough. Differential equation, vector calculus, transform theory, etc. Then solutions are lengthy. Solutions are tedious. Tedious means lengthy. Solutions are tedious, lengthy, but very accurate. But very accurate answer. But very accurate answer. Okay. So in distributed models, they are complex to represent. Okay. They use advanced maths. Okay. Like differential equation, vector calculus, transform theory. Solutions are tedious, but very, very accurate answer. But very, very accurate answer. Okay, now, but very accurate answer. That is the meaning. That is about distributed parameters. They are very, very accurate answers. Okay, now. Okay, so understand. Now I will give the conclusion. See, one way I told that lumped parameters are easy to represent. Yes, easy to represent, but approximate answer. Distributed are very complex but accurate. So the conclusion is, see, the lumped parameters are called abstract models. Abstract models. This is the best name, abstract. Sir, you all know what is abstract, na sir? Your sir will say, give me project abstract. Project abstract means the entire tough big project, like your BTech project, you will explain in one paragraph. Yes or no? Though it is a very complex project, but you will write in one paragraph or not. What is input, what is output, what is your aim and ambition, like that. So lumped models are like abstract models, simplified models, not giving thorough details, but very easy to understand. Okay, approximately you can understand. Yes or no? So lumped models are abstract. That is where electrical circuit analysis or network theory will come. So network theory is all about lumped models. Remember this. Network theory is all about lumped models. Now distributed parameters are called absolute models. Absolute models, very, very accurate models, sir. Very accurate models. Detailed analysis and detailed mathematics. So all our subjects like EMF, power electronics, etc. We take distributed models. So in lumped models are abstract models like circuit theory, networks, etc. But this EMF is a distributed parameters where accurate modeling we take. Okay, now there is a basic difference between lumped versus distributed. Okay, lumped versus distributed. Okay, now sir, I am giving an IES objective question. Okay, now carefully answer this. Okay, the relation V equal to n lambda. The relation, okay, V equal to n lambda, okay, is valid for dash parameters. Is valid for dash parameters. A. lumped only. B. Don't write all this, just pick the answer. Distributed only. C. Both for lumped and distributed, both for lumped and distributed. D. None. Okay. The relation V equal to n lambda is valid for dash parameters. Just answer. I am giving only 1 minute. Answer this. Okay, see now, I am asking this question that relation V equal to n lambda is valid for dash parameters. See, what is this equation? This is a fundamental physics equation which tells that velocity of a traveling wave is frequency into wavelength. Velocity of a traveling wave is frequency into wavelength. So to prove this equation, the physical length, see the physical parameter length must be considered. That means, yes, velocity of a traveling wave is frequency into wavelength. Wave equation is valid for any wave, sir. Electrical wave, flux wave, charge wave, voltage wave, current wave, ocean wave, electromagnetic wave, earthquake wave, like that. So this is a fundamental physics equation which tells that velocity of a traveling wave is frequency into wavelength. That means to prove this velocity at different points with frequency, I should consider the physical length variation. So physical length variation must be considered. To prove this, physical length parametric change must be considered. Physical length variation or parametric change considered. Parametric change considered means it is lumped or distribution. Parametric ranges are considered. So this is distributed model, sir. This is a distributed model. See, another hint is in this previous discussion itself I gave, see waveguide principles. See, waveguide principles are which I told us, sir, waveguide principles are distributed models. So answer is distributed only, because to prove this mathematical equation, physical length parametric change has to be considered. Then only I can prove this equation at different points. So this is valid for distributed models only. Understood now? This is valid for distributed models only. So now listen, sir, everyone. Important topic. Topological. Okay, topological definitions. Okay, definitions of network. Topological definitions of network. Okay, topological definitions. Okay, in the first node, node n, node n. Topological definitions of a network. Node n. Okay, a node is a point of interconnection or junction or junction between two or more components. Two or more components. Okay. A node is a point of interconnection or junction between two or more components. Okay. That is a simple meaning. Okay. Node is a point of interconnection or junction between two or more than two also. Even between two is a fundamentally node. Then what is a branch? Okay. Topological definitions means that these definitions give about the shape and interconnection of network. Okay. Branch B. A branch. Okay. A branch is an elemental connection, okay, between two nodes. Elemental connection between two nodes. Okay, a branch is an elemental connection between two nodes. Okay, then degree of a node. Degree of a node delta. Degree of a node delta. Okay, the number of branches. The number of branches incident at any node represents its degree. Okay, the number of branches incident at any node. Incident means connected. Okay, na? The number of branches incident at any node represents its degree. But if delta equal to 2, it is called simple node. Simple node n suffix s. But if delta greater than 2, it is called principal node. Principal node n suffix p. Okay, principal node, that is n suffix p. Okay, now then I am writing a note for any circuit or network. For any circuit or network, sigma delta I is 2 into number of branches, where I takes the value from 1 to b, okay, or 1 to n. Okay, see, sigma delta I is 2 into number of branches. What does it means? That is sum of degrees of all the nodes. Sum of degrees of all the nodes is 2 times the number of branches. Okay, na? Sum of degrees of all the nodes is 2 times the number of branches. Okay, sum of degrees of all the nodes is 2 times the number of branches. Okay, na? That you remember. Then mesh M. I will explain, sir. Don't worry. First, listen carefully. I told you, sir, first few hours all definitions will come, but they are important, sir. Now, what is a mesh? Mesh is a closed path. Mesh is a closed path of a circuit or network. Which should not have further closed paths in it. In it. Okay, mesh is a closed path of a circuit or network which should not have further closed paths in it. Then what is loop L? Okay, what is loop L? Loops are all possible closed paths of a circuit or network. Okay, na? Loops are all possible closed paths of a circuit or network. Okay, loops are all possible closed paths of a circuit or network. Okay, loops are all possible closed paths of a circuit or network. Okay, that is the meaning. Then I am writing a note. Now to understand, first listen this. Writing a note. First point. Okay, for any circuit or network. Okay, M is equal to B minus N plus 1. That is number of meshes equal to branches minus nodes plus 1. Okay, number of meshes equal to branches minus nodes plus 1. Okay, that is the meaning. Okay, that is the first thing. Okay, meshes equal to branches minus nodes plus 1. Then second point, the minimum number of KVL equations. The minimum number of KVL equations require to solve a circuit or network is also equal to m, that is b minus n plus 1. Okay, the minimum number of equations to solve a circuit or network is also equal to m. Then meshes are specifically called as independent loops. Okay, meshes are specifically called as independent loops. Then all meshes are by default loops. Okay, but all loops are not meshes. Okay, all meshes are by default loops, but all loops are not meshes. Okay, in nodal analysis, okay, we may neglect simple nodes. Okay, we may neglect simple nodes. Okay, and one of the principal nodes is reference. Okay, so in nodal analysis we may neglect simple nodes and one of the principal node is reference. So minimum number of KCL equations required to solve a circuit or network. Okay, the minimum number of KCL equations required to solve a circuit or network is NP minus 1. Okay, that is principal nodes minus 1. Okay, that is principal nodes minus 1. Okay, sir. Now we will understand everything. See, sir, everyone listen now. What are these topological definitions? Okay, this is important. Listen. I will take examples, sir. Don't worry. No need to by heart. After applying, you will remember everything. No need to by heart. What is a node? Node is a point of interconnection or junction between two or more components. A branch is an elemental connection between nodes. Then what is the degree of a node? The number of branches connected at the node represents its degree. If delta is 2, it is called simple node, but if delta is greater than 2, it is called principal node. Then this relation is very important. Sum of degrees of all the nodes is equal to 2 times the number of branches. Mesh is a closed path, which should not have further closed paths. Loops are all possible closed paths of a circuit or network. Then for any circuit or network, n is equal to b minus n plus 1. The minimum number of KVL equations required to solve a circuit or network is, yes, b minus n plus 1. Meshes are specifically called as independent loops. All meshes are by default loops, but all loops are not meshes. Okay. In nodal analysis, we may neglect simple nodes. And one of the principal node is considered as reference. Okay. So the minimum number of KCL equations are NP minus 1. I will explain, sir. Chalo, everything I am explaining here. Okay, we'll take one example, then we'll take a break. Chalo, one example, listen now. See, I am taking an example like this. Everybody watch this. Okay, I'm not taking any values, leave it. Okay, this is some AC voltage. Okay, this is some AC voltage. Okay, if you want values also, I can take, but okay. Now here I want nodes, branches, meshes, and also loops. Okay, first of all, node is a point of interconnection or junction between two or more components. Node is a point of interconnection or junction between two or more components. See, even between these two is a node. But what is the degree of this node? Because only two branches are connected. Its degree is 2 or rank is 2. Because it is a degree 2, it is called simple node 1. Now this is also junction between two branches. So its degree is also 2. So it is simple node 2. But this junction is connecting how many branches? 3 branches. This junction is connecting 3 branches. So its degree is 3. So it is principal node 1. Now this junction is connecting again two branches. This junction is connecting two branches. It is also simple node 3. Now this junction is connecting 1, 2, 3. So its degree is 3 greater than 2. So it is principal node 2. But this is not a node, sir. This is not a node. Please understand. Bends are not nodes, please. Bends are not nodes. Okay. Because this entire wire resistance is lumped here. This entire wire resistance is lumped here. So bend cannot be a node. Bend is not a node. Be careful with such things. So suppose if there is an element here, then this would have been a simple node. If there is an element here, then this would have been a simple node. But bends are not nodes, please. Okay. So it has got 3 simple and 2 principal. 3 simple with 2 principal, total 5 nodes. Branches are elemental connection between nodes. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, branches are 6. Then mesh is a closed path which should not have further closed path. See, this is one closed path which is not having further closed path. This is also one closed path which is not having further closed paths. So this is meshes are 2. That is also equal to branches minus nodes plus 1. Yes, that is also 2. Yes, meshes is equal to branches minus nodes plus 1. Branches minus nodes plus 1. Then loops are all possible closed paths. Loops are all possible closed paths. So first of all, two meshes are by default loops. Okay, even meshes are loops, please. Loops are all possible closed paths. Then apart from that, there is another closed path which is having further closed paths now, that is purely a loop. There is another closed path which is having further closed path, that is another loop. Total how much? 3. So meshes are 2, loops are 3. So that is why we do mesh analysis. That is why we do what? Mesh analysis. Now suppose I do this problem. Okay. Now suppose I do this problem by mesh analysis. Mesh analysis means what? KVL. KVL. The minimum equations are how many? M. M is how many? 2. So I write two currents, I1, I2 clock, and I will do like I1 here, I2 here. Suppose I do nodal analysis here. Now listen carefully. In nodal analysis, though there are total 5 nodes, now though there are total 5 nodes, everybody, though there are total 5 nodes, simple nodes are waste because they are series elements and I can lump them. Simple nodes you don't take. But one of the principal node I will take as a reference, and this will be like V1. So in nodal analysis, we write KCL. The minimum number of equations are NP minus 1. But NP, principal nodes are how many? 2. 2 minus 1. That is 1 only. So we take only one nodal equation and 2. So V1 minus Vs by Z1, V1 by Z2, V1 by Z3 like that. So in nodal analysis, we write KCL. That is NP minus 1. Okay. Principal nodes minus 1. Okay. So there are total 5 nodes. In that simple nodes we neglect, but one of the principal node we take as reference, and that equation only we are writing. Okay. Now here if I check, see everyone, if I check this formula, if I check sigma delta I, now listen, sigma delta I, what is that I am trying to do? I am adding all the degrees. See, degree of this simple node is 2. Degree of this simple node is also 2. Okay. Degree of this principal node is 3. Then degree of this simple node is 2. Then degree of this principal node is 3. So total, if you add how much you are getting, 6 plus 6, 12. So that is nothing but 2 into 6 now. But what is 6? 6 is the number of branches now. That is 2 into number of branches. So sigma delta I is 2 into number of branches. Okay now? Okay, I will repeat this, sir. We will take a break. Now it is 8:32. So come back by 9:02. In my watch, it is 8:32. So come back by 9:02. Everybody take a break. Come back by 9 o'clock. Okay. We will repeat, sir. Don't worry. I will repeat again. Slowly we will go. Okay. Take a break. Yeah, good morning, everybody. Please come back. Still, some students need to join, around 20 students. Don't log out, sir. Okay, I suggest don't log out and log in again. Okay, so please, everybody, come back. Chelluri Sharath, PCB's printed circuit board. See all our computer. Chelluri Sharath, can you raise your hand? Sharath, what is PCB? Printed circuit board. Our computer motherboard, TV motherboard, they are all called printed circuit board. Practically, while analyzing, we do lumped models. Yes, that is how much accuracy it depends upon. Yes, practically we use lumped, but the solution is not 100% accurate. So in design stage, they use distributed parameters. Analysis stage, they use lumped parameters. So this anonymous certainty. Who is this anonymous certainty? Raise your hand. Anonymous certainty, raise your hand. Your Bhavana. Again, raise your hand. Bhavana. Bhavana, can you talk? Bhavana, I give.
Yes, sir.
Your name is like anonymous attendee there, right?
Yes, sir. Just by mistake went tick on the
No problem. See, tomorrow you change it to Bhavana, okay?
Yes, sir.
No, I don't want like anonymous attendee because I want to know any. See, sometimes in our coaching also, some students they log in with the user ID of their friends like that. There is a problem. Okay, we don't want. Okay, that is why. See, some friends share the user ID with others, and that is a problem here. Okay. So Bhavana, tomorrow you write your name there and not as anonymous attendee. Now Bhavana, listen. See, how much accuracy you want based on that we take. See, actually in design stage we use distributed parameters. Okay, in design stage we use what distributed parameters, but for analysis we use lumped parameters. Like circuit theory, we simplify everything and do lumped only. But in field theory, if you want accuracy, go for defined. That is distributed parameters. So how much accuracy you want, that depends. Like in power system, both we do, na sir. See, Bhavana, we do both in power system. Like what happens for short line, medium line, we use lumped, but for more accuracy, long line is an accurate model.
Yes, sir. Yes, sir.
So that is the meaning. So practically we do both, but how much accuracy you want, you decide. Based on that, you do. At design level, we do distributed, but at analysis level, we do lumped model. Okay.
Okay, sir. Yes, sir. Thank you, sir.
Okay. Some student, Sangeeta, raise your hand. Sangeeta, raise your hand. Sangeeta, raise your hand. I will teach slowly, sir. Don't worry. See, initially, Sangeeta, can you, can you raise your hand, Sangeeta? Can you talk with me? I give permission to talk. Sangeeta, can you talk? Sangeeta, I give permission to talk. Okay, but anyhow, Sangeeta, can you listen to me?
Yes, sir.
I will see initially this first 4 or 5 hours will be like this. Don't worry. But sir, what you do, these definitions and formulas, what I'm writing, you revise today, tomorrow, because it's all basic definitions. But once I start analysis, na sir, there I will go very slow. Okay.
Okay, sir.
Because these are all see in online coaching what is happening now, sir. I have to write everything in class. At least what I would have done slowly, I would have dictated, I would have explained like that. But here, what is happening now? Everything we are supposed to write. That is why it is looking like hurried. But in normal class, na sir, I would have dictated very slowly and neatly, and that would have saved my energy. But here, what I'm doing is everything point to point I'm writing, na sir. So it looks like hurried. Okay.
Okay, sir.
But after these basic definitions are over, na sir, then we will do very carefully. Then the real network theory analysis will be very interesting. Okay.
Okay, sir.
So you will feel like that, but later you'll enjoy it. Don't worry. Okay.
Okay, sir. Thank you.
Okay. Then Anil Kumar. Okay, we gave a lot of game gave answers. Distributed parameter only. Very good. Lumped is wrong answer for that bit. Okay, no problem. See, I want answers. That is very, very interesting. Yes, I want answers from you, sir. I really want answers from you. Whether it is correct or not, no problem. But I want answers from you. Okay. Don't worry. I don't mind if it is camera swine. Bimalendu swine. Raise your hand. Now see here, there is an internet problem. I am using BSNL. The problem in my side is internet is very low speed. In
Okay,
B,
sir. Okay, sir.
actually in BHL colony, they are not allowing Jio Fiber and Airtel. Yeah, it is a problem in. I stay in BHL MIG colony. Here, government area, na sir, they are not allowing these people to come.
Okay, okay, sir. No problem.
No, that is why. See, I tested even in other batch in August also. When I turned on camera, it is going blur, very blur, and students told that. So better, okay, when necessary, I will interact. No problem. Okay.
Okay.
Okay. Okay, chalo, now we will go again. Yes, everybody. Chalo, thank you for your cooperation, sir. We will go further. Now, sir, listen, everyone. See, we are now talking about topological definitions. What are topological definitions? See, these definitions give the information about network and its arrangement. Okay, these topological definitions give information about network and its arrangement. How many elements are there, which are connected, what is the degree, what is the shape, how many mesh equations to solve, how many nodal, like that. So what is this definition? First node definition I give. Okay, na? Node is a point of interconnection or junction between two or more components. Okay, na? Branch is an elemental connection between nodes. Degree of a node, these number of branches incident. Incident means connected. Okay, simple node NS, principal node NP. Then relation between degree and branches, that is sum of degrees of all the nodes is 2 times the number of branches. Then mesh is a closed path which should not have further closed paths. Loops are all possible closed paths. Okay. Then I told for any circuit or network, M is equal to B minus N plus 1. This second point, the minimum number of K-wave equations to solve anything is also M only. Meshes are called as independent loops. Okay, remember that. And all meshes are by default loops, but loops are not meshes. Why? Because mesh is a closed path which should not have further closed path. But mesh is an independent loop. That is a different. But all meshes are loops, but all loops are not meshes. Okay. Then in nodal analysis, we neglect simple nodes, but one of the principal node is taken as reference. So the minimum number of KCL equations are NP minus 1. Now see this. All this I will explain here. See in this example, first nodes are how many? See, this is simple node because it is connecting only two. This is also simple node connecting only two. But this is connecting 3 branches. So degree is 3. So this is principal node. And this is again simple node because it is connecting only 2. And here this is principal node connecting 3. That is why NS1, NS2, NS3 means simple nodes. NP1, NP2 means principal nodes. Why? Because this principal nodes degree is greater than 2. That means more than 2 branches are connected. But this bend is not a node, sir. Remember, bend is not a node. So nodes are total 5 branches. Elemental connection between nodes. So 1, 2, 3, 4, 5, 6. All the working elements are branches. There are 6 working elements, 6 branches. Mesh is a closed path which not have further closed path. 2 meshes. Loops are all possible closed paths. So meshes are by default loops 2 plus another closed path is also 3. Then check this formula, that is sigma delta I. That means I am adding all the degrees. See, this simple nodes degree are 2, 2, 2, but this principal node degree is 3 and this principal node degree is 3. So total 6 plus 6, 12. But the 12 is 2 into 6 now. But what is 6? 6 is number of branches. So sigma delta I is 2 times the number of branches. That is what I wrote here. Okay, na? Sigma delta I is 2 times the number of branches. That is what I wrote here. Okay, na? Then if I solve this problem by mesh analysis, I require 2 equations. But if I solve this problem by nodal analysis, I require only 1 equation. So here also nodal is faster. Okay, chalo, now I am giving the real example, sir. Now I want everyone to work carefully and then we will have a discussion. Okay, na? Chalo. Now this is a question. Everyone should try this. Take a rough paper, take a pen, pencil. Okay, na, sir. Chalo. Now I'm giving a network. Okay. I'm not giving any values here. So values are not important. Okay, just tell me such answers about topological definitions. Chalo. This is some voltage source. This is some current source. Okay, don't worry about the values. Now carefully, sir, everybody tell me how many nodes, how many branches, how many meshes, and how many loops. Chalo, I'm giving you 2 minutes. Everyone carefully tell me how many nodes, branches, meshes, and loops. Chalo, quick. Okay, now everybody should listen now. See, first nodes, sir. See, better I always write first simple nodes. Better I always write first simple nodes. What are simple nodes? Simple nodes connect only two branches. See, this is simple node 1. This is simple node 2. This is simple node 3. Okay, then this is simple node 4. This is simple node 5. This is simple node 6. This is simple node 7. This is simple node 8 because simple nodes connect only two branches and their degree is how much? 2. So first select all simple nodes. That is easy. So I find the total 8 simple nodes. Now principal node. Now see, this node is connecting how many branches? 3 branches, na sir. So it is incident with 3 branches. So its degree is greater than 2. So this is principal node 1. Now this node is also having how many branches? 1, 2, 3, 4. 1, 2, 3, 4. It degree is 4. This is also principal node 2. Okay. This is principal node 2. Okay, principal node. Now, yes, now this and this cannot be different nodes. See, there is no element here. In fact, it is a direct wire connection. In fact, it is a direct wire connection, ideal wire. Ideal wire is not an element. Together, this is a single node. Together, this is a single node. Okay, together, this is a single node whose degree is how much? 1, 2, 3, 4, 5. See, this ideal wire is not an element. If there was an element, then I would have differentiated these nodes. But again, this is a single node because same wire connected. The potential of this point equal to potential of this point. In fact, this branch are parallel. So this together is a single node. So 1, 2, 3, 4, 5. Degree is 5. So it is principal node 3. So I say there are 8 simple and 3 principal. Total nodes are 11. Okay, now total nodes 11 branches. All working elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 branches. 14. This cannot be a branch, sir. See, this cannot be a branch because that is ideal wire is not an element. Ideal wire is a concept in electrical engineering which does not have zero resistance, infinite conductance like that. It is not an element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Meshes. How many clearly 4 na, sir? 1, 2, 3, 4. So 4 meshes. That is also equal to branches minus nodes plus 1. That is also 4. That is also 4. Okay. Meshes are also 4. Now loops are all possible closed paths. Loops are all possible closed paths. Loops are all possible closed paths. So meshes are by default loops. Okay. Meshes are by default loops. Plus 2 meshes together is a loop. 2 meshes together is a loop. Okay. These 2 meshes, one loop. These 2 meshes, second loop. These 2 meshes, third loop. So 2 meshes is also loop, like that 3 are there. 3 are there. Plus 3 meshes together is also a loop. Okay, 3 meshes together is a loop. Now this 1, 2, 3. This entire thing is one loop. Okay. Now this 1, 2, 3. This entire thing is also second loop. So 3 meshes together is also a loop. Like that 2 are there. Then all 4 meshes together. So then all 4 meshes together is also a loop. Okay. Then all 4 meshes together is also a loop. So if you take this all 4 meshes together, that is also a loop. Okay. That is also a loop. That is 1. So 4, 3, 2, 1. Total how many loops? 10 loops. Okay. Total how many loops? Yes, I say total 10 loops. 10 loops. Okay. First of all, meshes are by default loops are. Then 2 meshes together. The yellow paths. Yellow paths are 2 meshes together is a loop. Then pink paths. 3 meshes together loops like the 2. Then all 4 meshes together is also a loop. So total 10 loops are there. Okay. Now, sir, let us check this. Sigma delta I. Okay, now I will add all the degrees. Now there are 8 simple nodes. 1, 2, 3, 4, 5, 6, 7, 8. 8 simple nodes with degree 2. Total 16 plus principal node 1 degree 3 plus principal node 2 degree 4 plus principal node 3 degree 1, 2, 3, 4, 5. So total it is 16, 19 plus 9, 28. That is also equal to 2 into 14. 2 into 14, that is 2 into number of branches. 2 into number of branches. Okay, so sigma delta I is 2 into number of branches. Now, sir, in this problem, suppose I do mesh analysis. Mesh analysis, how many meshes? Yes, 4 equations. So KVL equations are how many? 4. M is equal to 4. So 4 mesh equations like I1, I2, I3, I4. 4 meshes equations, I4. Okay, so 4. Suppose I do nodal analysis. Nodal analysis is about solving by KCL. Nodal analysis KCL. The minimum number of equations are NP minus 1. NP minus 1. See, there are how many total? See, all simple nodes I can neglect. but there are three principal nodes. All simple nodes I can neglect, but there are three principal nodes. Okay, but there are three principal. One of the principal node I will take it as reference. One of the principal node I will take it as reference. Then automatically this is V1 and this is V2. So principal nodes are three. 3 minus 1, 2. So I will take two node equations V1 comma V2 and I will solve. So simple nodes I can neglect. Why? Because these are all series. Now you can lump into single impedance like that. Plus JXL R1 minus JXC altogether I will lump into single impedance. So like V1 minus V2 plus Vs whole by Z1 like that I can write. Okay. Chalo. We will do such sir. Don't worry. Mesh and nodal we will have a separate chapter. Don't worry. So here the answers are nodes are 11, branches are 14, meshes are 4, loops are 10. And sigma delta I verified. Mesh equations are KVL 4, nodal equations are KCL 2. Okay, so here also nodal is faster because only two equations. So now I am asking another interesting question. Everyone should answer this. Okay, some 10 volt, 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 amperes, 6 ohm, 7 ohm. How many nodes? How many branches? How many meshes? Here also I am giving question. So here also, how many nodes, how many branches, how many meshes. So I'm giving you 2 minutes. Everyone should answer this again. 2 minutes only, please. Yes, everybody, listen now. See here, purposefully I gave some open circuit. Now listen carefully, sir. Listen carefully, okay? See, first of all, node is a point of interconnection or junction between two or more components. See, this cannot be a node. Why? Because here there is no other component. Nah, in fact, there is no component. It is open circuit. So that cannot be a node as per definition. Even this is also not a node. Even this is also not a node. Okay? Because node is a point of interconnection or junction between two or more components. This is also not a node. Okay, even this is not a node, this is not a node. So automatically, can these be branches? No, because branch is an interconnection between two nodes. Branch is an interconnection between two nodes. So when this cannot be a node, this cannot be a branch. This is not a working branch. In fact, open circuit in series to passive elements are waste. Open circuit in series to passive elements are waste because current cannot flow. So no current, no voltage, no power, no charge, no energy, nothing. Okay, and that is the first thing, sir. Chalo. Now we neglected unnecessary part. It is a network actually. It is a network. These two ohms and 4 ohms are unnecessary. Remaining is circuit. So now this is now simple node or principal node. Because this 2 ohms is not a working branch. Here only two working branches. So degree is 2 only. So this is simple node 1. Here also this is simple node 2 because this 4 ohms is not a working branch. So simple node 2. This is simple node 3. Okay. So simple node 3, but this is principal node with degree 3, and this is also principal node with degree 2, degree 3. So I say there are 3 simple and 2 principal. Total nodes are 5. Then branches are elemental connection. 1, 2, 3, 4, 5, 6. These cannot be branches, na sir. These 2 ohms and 4 ohms are not working branches. So 1, 2, 3, 4, 5, 6. Okay, that is 6. Okay, then mesh. Now because this is open, everybody please understand. Because this is open, this together is one mesh, and this together is second mesh. So meshes are 2. That is also equal to branches minus nodes plus 1. That is branches minus nodes plus 1. Branches minus nodes plus 1. Okay, branches minus nodes plus 1. Okay. Now, sir, everyone listen now. Yes, everyone listen now. I am coming to the next example. Chalo, in that regard, everybody. Now this is simple node. Okay. This is also simple node 2. But this is principal node connecting 3. But now here this and this cannot be 2 different nodes. In fact, this is only a single node. This together is a single node. Everybody please understand, this together is a single node only. In fact, short circuit across passive elements are also redundant. Here open circuit in series to passive elements are waste. Here short circuit in parallel to passive elements are waste. Because here current cannot flow as there is no potential difference. See, I told current requires 2 conditions. What are the 2 conditions? First, there should be a driving force or EMF. Second, there should be a closed path. Yes or no? Current requires 2 conditions. First, there should be a driving force or EMF. Second, there should be a closed path. Here, driving force potential difference may come, but closed path is not there. So here everybody please understand that here open circuit in series to passive elements are waste. Here short circuit in parallel to passive is also waste. Short circuit in parallel to passive is also waste. Because current requires 2 conditions now, sir. One driving force, second closed path. Here potential difference may come, but closed path is not there. Here closed path is there, but where is the potential difference? Because this point and this point are at same potential. Na? So short circuit in parallel to passive elements are also waste. Open circuit in series to passive elements are also waste. So that is why here these are not working elements. Now what is, now I am removing this. Chalo, I am removing this. Please understand, because this is not working as short circuit is across. Now what is the degree of this node then? 1, 2 and 3. Because 1, 2 and 3. So it's degree 3. So this is principal node 2. So here 2 simple, 2 principal. Total 4. Okay, 2 simple and 2 principal, total 4. Now branches. Branches are 1, 2, 3, 4, 5. Branches are 5. Then mesh. How many meshes are there? Yes, 2 meshes are there. 1 and 2. Meshes are 2. That is also equal to branches minus nodes plus 1. So open circuit in series to passive elements are waste, and short circuits in parallel to passive elements are also waste. That is why first you should consider which is the working part, and then we should do. Okay, first we should consider which is the working part, and then we should do. Okay, now sir, this is a gate question I am asking. Everybody, I'm coming to gate question. Chalo, carefully listen and answer. The minimum number of equations, the minimum number of equations required, okay, to solve the circuit below is dash. The minimum number of equations required to solve the circuit below is dash. The minimum number of equations required to solve the circuit below is dash. He is never mentioning mesh or nodal. He is just asking the minimum number of equations required to solve the circuit. So whichever is minimum, that will be the answer. It is a gate question 2007. Now this is Vs, this is Rs, this is load resistance RL, this is C1, R1, this is R2, C2, R2, C2. Okay, and here 2, 3, 4, and 5. Okay, the minimum number of, please understand, the minimum number of equations required to solve the circuit below is dash. The minimum number of equations required to solve the circuit below is dash. Okay, the minimum number of equations required to solve the circuit below is dash. Okay, so understand, sir, he is never mentioning KVL or KCL. Minimum number of equations. So whichever is minimum, that is the answer. So try it immediately. Everyone try this, please. Yes, time up. Listen now, everybody. See the minimum number of equations. So here he did not mention KVL or KCL. So whichever is minimum, that is the answer. Na? So I will check both, sir. Listen, I will check both. Suppose if you solve by mesh analysis, that is KVL, you know the minimum number of equations are what? M. where m is equal to b minus n plus 1. This circuit looks confusing, so I will use the definition. First of all, how many nodes? See, this is simple node 1. Yes or no? This is simple node 1. But this is principal node 1. This is principal node 2. This is principal node 3. This is principal node 4. Now this together is a single node. This together is a single node. Okay, this is a single node with degree 1, 2, 3, 4. Okay, this is also principal node 5. So this is simple node, principal node 1, principal node 2, principal node 3, principal node 4. And this together is a single node with degree 4. Okay, so this is simple node, principal node 1, principal node 2, principal node 3, principal node 4. This together is a principal node 5 with degree 4. So there are 5 principal and 1 simple, total 6 nodes. Okay, total 6 nodes. Okay, now branches 1, 2, 3, 4, 5, 6, 7, 8, 9. Branches are 9. Branches are 9. So 9 minus 6 plus 1. So that is clearly how much? 4. That means if you do mesh analysis KVL, the minimum number of equations are 4. Sir. But what about nodal? Check nodal. The minimum number of nodal equations KCL are NP minus 1, NP minus 1. Let us check it. Now see, there are total, simple nodes are waste. There are total 5 principal. In that 5 principal, I will take one of them as reference. So 5 principal minus 1, this is also 4. So it is such a unique problem. Yes, this is such a unique problem. Whether you do mesh analysis or nodal analysis. Yes, whether you do mesh analysis or nodal analysis, the minimum number of equations are how many? 4 only is the answer. Because in this problem, whether you do mesh or whether you do nodal, answer is 4 only. Understood? Answer is 4 only. So yes, I checked KVL, I checked KCL. Both are giving 4, so answer is 4. Suppose mesh is 3, nodal is 4. Mesh is 3, nodal is 4, answer is 3. Suppose mesh is 3, nodal is 2, mesh is 3, nodal is 2, answer is 2. Like that. Okay, now mesh is 3, nodal is 2, answer is 2. Like that. Okay. So the minimum number of equations are only 4 here. Now I'm asking another question. The above previous network is planar or not? Planar or not is my question. See, the above previous network is a planar network or not? Please understand my question. The above network is planar or not planar? See, as long as you can represent any network in a single plane. Okay, as long as you can represent any network in a single plane without overlap. Okay, as long as you can represent any network in a single plane without overlap, it is called planar network. Okay, as long as you can represent any network in a single plane without overlap, it is called what, sir? Planar network. Okay, as long as you can represent any network in a single plane without overlap is called what? Planar. Please understand this. But if you cannot represent in a single plane, then it is a non-planar. Okay, but as long as you can represent any network in a single plane, it is called planar. If you cannot represent in a single plane, then it is a non-planar. Then it is a non-planar. See now this network, how I am representing, you see. Okay, see this C2, this capacitor C2 is looking overlapping now, sir. See, but I will write like this. See, I will write everything like this in a single plane. I will try to write everything like this in a single plane. Okay, I will try to write everything in a single plane like this. This is Vs, this is Rs, listen, this is C1, C1, R1, this is R2, R2, C2. Okay, values are not important. And this is RL. See, is this planar or not? See, as long as you can represent in a single plane without overlap, it is planar or not? See now, this capacitor C2, which is overlapping and confusing here, watch this. This capacitor C2, which is confusing and connected like this, I can write like this, sir. Between the same two nodes, I can write like this. Yes, I can write like this. Nothing wrong. See, it is again connected between same two nodes only. So after writing this, now clearly, yes, this is planar. Now clearly, how many meshes are visible? 4. So planar only. Yes, planar. As long as you can represent any network in a single plane without overlap, it is called what network, sir? Planar network. Planar network. Okay, this is all planar networks. Okay. Okay, now I'm asking a question. Now I'm asking question. The circuit below, okay, the circuit below is planar or not? Okay, now the circuit below is planar or not? Okay, my question is this, sir, everybody. Okay, I'm giving the circuit here and I'm asking whether it is planar or not. Okay, the circuit below is planar or not? That is my question. Answer carefully. The circuit below is planar or not? Okay, the circuit below is planar or not? Okay, this is like 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 2 ohm, some 5 amperes. So the circuit shown is planar or not? Chalo, check carefully and tell me the answer. The circuit shown is planar or not? Yes, this is planar only. Okay, let me see how many wrote correct. Yeah, some students wrote planar, but I say it is, yeah, planar only, sir. Let us see why. See, what I will do is I will do node shifting technique. Node shifting. Let us say this is node 1. I will give nodes, okay? Node 1, This entire thing is 1. Please be careful. Okay, na? This is node 2, and this entire thing is node 3, and this is node 4. Okay, na? See everyone, please observe. Okay, there are total 4 nodes only. This entire thing is node 1, this is node 2, node 3, and node 4. I'm doing like this. I'm doing shifting. Okay, see 4 I will do here. Okay, to remove the confusion. 4 I will do there. Okay, 2 I will put here. Then 3 I will put here. Okay, 3 I will put here. Okay, and 1 I will put here. Okay, I will show another way. See, I want to take like this. See, I will take this one here so that for me easy to represent. Chalo, 4 I am putting here. Okay, any shape you can take. Then 2 I will take here. Okay, adjacent to 2 this is 3 and this is 1. Like that I will take. Okay, my shapes are no problem. Node shifting. Chalo, now listen. See, 1 to 2 1 ohm. Okay, 1 to 2 1 ohm. Okay, then 1 to 4 1 ohm. Okay, 1 to 4 also 1 ohm. Okay, na? Then 3 to 4 1 ohm. Okay, 3 to 4 1 ohm. 3 to 2 1 ohm. Okay, 3 to 2 is also 1 ohm. Then 4 to 2 2 ohms. Okay, 4 to 2 2 ohms. And finally 1 to 3 5 amperes. 1 to 3 5 amperes. I will write like this. See, 1 to 3 5 amperes. So, but it is hitting 3. Okay, like that. So clearly it is planar only. Okay, na? Clearly the network is planar. Okay. So I'm giving another question. Okay, I did something called node shifting. I call this as node shifting. Node shifting means reshaping network, sir. Don't confuse. Node shifting means reshaping the network. After reshaping the network, I identified this planar network only. Okay, na? Yes. Now, sir, I'm giving another interesting question. Network below is planar or not? Is planar or not? Okay, network below is planar or not? Okay. Okay, values are not important. Chalo. Now network is planar or not? That you answer. Okay, that you answer, and also answer here how many nodes, how many branches, and how many meshes. Chalo, everyone answer this immediately. Yes, everybody listen. Yes, this is also planar, sir. This is also planar. See, initially what everyone feel, listen. Initially what everyone feel is there are total, see, 1, 2, 3, 4, 5, 6, 7, 8, 8 corners. So we feel 8 nodes. Branches also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12. Now this is a problem that everyone feel, array there are 6 surfaces. Yes, everyone feel there are 6 surfaces. Though, so you may say 6 meshes. But if you check, meshes equal to branches minus nodes plus 1. See, if you check, branches are 12. 12 minus 8 plus 1, how much is coming? That is 5 only. That is coming 5 only. Yes, that is coming 5 only. Please understand. Meshes equal to branches minus nodes plus 1. That is coming as 5 only. Okay. Yes, that is coming 5 only. But generally everyone may feel, array yaar, there are 6 surfaces and you may write 6, but actually this is 5 meshes only. Now let us understand why 5 is correct. Now again I will do node shifting technique. See, let us say this is node 1, node 2, node 3, node 4. Okay, now node 5, node 6, node 7, node 8. Okay, I will take first 1, 2, 5 and 8 outside, and remaining 4, this 3, 6 and 7 inside. 7 inside. Okay, and 7 inside. So now if you observe, 1 to 8. Chalo, 1 to 8, there is voltage. 1 to 8 voltage. 1 to 2. Okay, then 2 to 5. 5 to 8. Similarly, 4 to 3. 3 to 6. 6 to 7. 4 to 7. Then 1 to 4. 2 to 3. 5 to 6. And 7 to 8. Yes, this is planar only. Yes, this is planar. First thing is planar. Now after writing planar, clearly how many meshes are there, sir? See, after writing planar, 1, 2, 3, 4, 5. Yes, meshes are 5 only. Yes, after writing planar, I conclude that meshes are how many? Meshes are 5 only. That is correct answer. Okay, meshes are 5 only. Please understand, sir, how interesting and important this problem is. Okay, so initially we thought everyone array it is a 3-dimensional non-planar we thought, but actually it is planar. And moreover, initially we thought 6 surfaces, 6 meshes, but after making it planar, now we got 5, which is correct answer. So that is why you see now in this problem also initially it was confusing. But after writing planar, how many meshes came? 4, na? How many meshes came? 4, which is correct here. Yes or no? Here also initially confusing. After writing this 3 meshes. Here also confusing, but after writing this 5 meshes. That means there is some link between planar arrangement to mesh analysis. So this question was given in IES. Now that IES question was, yes, mesh analysis. Listen carefully. Mesh analysis require what's up? Mesh analysis require planar arrangement in the network. Planar arrangement in the network. That is very interesting, sir, in the network. So mesh analysis require planar arrangement in the network, but nodal is superior, sir. That is where I will say nodal is superior. So mesh analysis require planar arrangement. Okay, but nodal is superior. So that is why now example of a okay, example of a non-planar network. Okay, non-planar network. Now I'm giving an example of a non-planar network. Okay, yes, I'm giving now example of a non-planar network. Okay, this is a non-planar network you see now. Okay, I'm writing this example. Okay, I'm giving an example of a non-planar network. Okay, everybody, I'm giving an example of a non-planar network. Now, this is an example of a non-planar network. Yes, values I'm not giving, but you test it, sir. Okay. So this is an example of a non-planar network. Nodes I'm highlighting. So this is an example of a non-planar network. Now you try to write this in a single plane, it is not possible. So this is an example of a non-planar network. So when non-planar network comes, better do nodal analysis. Better do nodal analysis. Nodal analysis for non-planar network. Non-planar network. Understood now, sir? So everybody please understand what I'm trying to say. So if I link everyone, see this question, minimum equations are 4, whether you do mesh and nodal. But after writing this is planar. Now after writing planar, only clearly 4 meshes. Here also this looks confusing, but after writing this, it is a planar and 3 meshes. Here also looks confusing, but after writing this is a planar network and mesh equations are 5. So mesh analysis require planar arrangement in the network. Okay, now please understand, mesh analysis require planar arrangement in the network. Okay, and this is an example of non-planar network. Okay, some values, okay, 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, 6 ohm, 7 ohm, 8 ohm, some 9 amperes. Okay, you check it. This is a non-planar network. Okay, a non-planar network. Please understand. This is a non-planar network. Okay, chalo, now I'm giving a very interesting IES objective. IES objective. Okay, a network has n principal nodes only. Okay, a network has n principal nodes only and b branches. Okay, a network has n principal nodes only and b branches. If if mesh analysis is simpler than nodal analysis, okay, if mesh analysis is simpler than nodal analysis, then n is greater than dash. N is greater than dash. Options are b minus 1. Okay, options are b minus 1 and b plus 1. This is b by 2 minus 1. This is b by 2 plus 1. Okay, if a network has n principal nodes only and b branches. Okay, a network has n principal nodes only and b branches. If mesh analysis is simpler than nodal analysis. Okay, if mesh analysis is simpler than nodal analysis, then n is greater than dash. If mesh analysis is simpler than nodal analysis, then n is greater than dash. Chalo, do it, everyone, do it. 1 minute. Okay, now let us see this solution. A network has n principal nodes only. See, please understand this network. He is saying there are only principal nodes and B branches. And if mesh analysis is simpler than nodal analysis, n is greater than dash. See, when can be mesh simpler than nodal? See, mesh analysis can be simpler than nodal analysis if number of the mesh equations are less than nodal equations. That is what meaning of simpler, na sir. See, if mesh analysis or mesh equations is less than nodal equations, then automatically it is called simpler, faster. Okay, but you know mesh equations are trivial, that is branches minus nodes plus 1. Okay, and he said here all the nodes are principal nodes only, like all the nodes are principal. Then in nodal analysis, one of the principal node is taken as reference, np minus 1. So if you shuffle them, this is b plus 2 is less than 2n. So b by 2 plus 1 is less than n. So n is greater than b by 2 plus 1. So n is greater than b by 2 plus 1. N is greater than b by 2 plus 1. So yes, here all principal nodes only he told. Okay, so n is greater than b by 2 plus 1. Okay, na? So now I am going to something important called Ohm's law. Okay, na? Ohm's law. Now Ohm's law is a big rule in electrical circuits, sir, in engineering itself. Okay. Now Ohm gave his law in total 3 domains. Ohm gave his law in total 3 domains, and there are total 9 forms of Ohm's law. There are how many? Total 9 forms. First I will discuss 6 forms, and later when I come to frequency domain analysis, there I will discuss another 3 forms, total 9 forms. So first Ohm gave his law in linear time invariant domain. Okay, linear time invariant domain. In linear time invariant domain, first of all, temperature is constant. Temperature is constant. Okay, na? And also assume uniform cross-sectional area of material. Cross-section area of material. Okay, here temperature is constant and assume uniform cross-sectional area of material. Then the first form of Ohm's law is J is sigma E. J is sigma E. Okay, this is the first form of Ohm's law. Okay, this is first form. Please understand, the first form of Ohm's law is this. So, where J is electric current density. Okay, J is electric current density. Okay, and sigma is called conductivity, and E is called electric field intensity, Okay, please understand. This is the first form of Ohm's law, that J is sigma E. It is valid in solids, liquids, gases, in any domain. That is called first form of Ohm's law. But this is not applicable to circuit theory, because circuit theory is lumped. This is applicable in field theory. Okay, this is applicable in field theory distributed. So how to modify for lumped parameters? Now see here. Now current density is current by area. This J I will write current density, current by area. This is sigma E. Electric field intensity is voltage by distance or voltage by length. Distance is nothing but length. So here V is okay, L by sigma A into I. But since 1 by sigma is called rho. Rho is called what? Resistivity. Rho is called what? Resistivity. Okay, resistivity. So I will say V is rho L by A into I. V is rho L by A into I. That is V is Ri. V is Ri. V is Ri. So this is the second form of Ohm's law. Second form of Ohm's law. Okay, that is the meaning. So that is how we derive second form, which is applicable in which lumped parameters. Why in lumped parameters I told us length, area, material, all are fixed. They are not varying. So this is a second form of Ohm's law. That is why I say any material in LTI domain can be modeled in terms of what? Resistance. So resistance represents linear time invariant property of matter, and its units are ohms. Units are ohms, omega. Okay, so resistance represents linear time invariant property of matter, and its units are what? Ohms. Now graphically if I show, yes, yes, the same thing if I show graphically. See, I'm writing here graphically. Okay, graphically if I show, like I is B by R. Okay, B by R, like Y equal to mx. So there is a meaning that it is y equal to mx. Y equal to mx. Okay, y equal to mx. Okay, na? Y equal to mx. Okay, y equal to mx. So the slope is 1 by r. Slope is 1 by r. Y equal to mx. That is why obeying Ohm's law means, from graph I can say, obeying Ohm's law means here. Obeying Ohm's law means our material is first of all linear. Yes, it is linear. Okay, linear. Passive, yes, it is passive because quadrant 1 and 3. Bilateral, yes, they are also bilateral because mirror image. So obeying Ohm's law means it is understood that the material or component is linear, passive, bilateral. Obeying Ohm's law means the material is linear, passive, bilateral. That is a big interesting concept. Then Ohm gave his law next in electromagnetic domain. Electromagnetic domain. Now he said that this psi is Li is a linear relation. Ohm identified this is a linear relation. Okay, this is the third form of Ohm's law. Third form. But what is this psi? This capital psi is okay n phi, which is called flux linkages. This is called flux linkages. Flux linkages in Weber turns. So I will write n phi is Li. But you cannot implement this directly in network theory because flux cannot be lumped. Yes, you cannot implement this directly in network theory because flux cannot be lumped. Then I will apply the principle of linearity. What is the principle of linearity? Though every system is non-linear, but for small incremental changes, I can make it linear. So I will differentiate n d phi by dt plus phi dn by dt is L di by dt plus I dl by dt. Now here, lumped concepts. If number of turns are constant, this is 0. And in lumped parameters, permeability is constant, uniform. If permeability is uniform, inductance is constant. In lumped parameters, I told you, sir, everything is not changing. Nothing should change. So in lumped parameters, if permeability is medium, it's constant, then inductance is constant. Differentiation of constant is 0. Then n d phi by dt is L di by dt. But what is this n d phi by dt? This n d phi by dt is nothing but Faraday's law. Voltage is L di by dt. See, this is the fourth form of Ohm's law. This is the fourth form of Ohm's law. Okay, fourth form. That is why if I model anything in electromagnetic domain, I will model it in terms of inductance. Inductance represents electromagnetic property of matter, and its units are Henry. That is how they came, sir. Units are Henry. Then graphically, here also, if I show graphically, yes, graphically, that psi is Li. If I show graphically, that psi is Li. That psi is Li. That psi is Li. Okay, your slope is inductance. Slope is inductance. Okay, graphically, psi is Li. Slope is inductance. Okay, so graphically this psi is Li, that is Ohm's law, or I can also say this V is L di by dt. Okay, this V is L di by dt. Okay, that is the meaning of obeying Ohm's law graphically. Okay, again obeying Ohm's law graphically means our inductance is linear, passive, bilateral. Okay, so now Ohm also gave his law in electrostatic domain. Electrostatic domain. Okay. What he told in electrostatic domain, this Q equal to CV is the fifth form of Ohm's law. Fifth form. Okay, fifth form. Okay, this is fourth form. Now this is fifth form. Okay, this is fifth form. But you cannot directly apply into circuit theory because circuit theory is lumped. This is applicable in field theory. So I'll apply the principle of linearity. For small changes, everything is linear. So if I differentiate this, dq by dt is c dv by dt plus v dc by dt. Okay, v dc by dt. But again, in lumped parameters, if permittivity of the medium is constant, then capacitance is constant. If permittivity of the medium is constant, capacitance is constant, then this becomes zero. Then this dq by dt is c dv by dt. But what is dq by dt? Current. So I is c dv by dt. This is the sixth form of Ohm's law. Sixth form of Ohm's law. So that is why any material in electrostatic domain can be modeled in terms of capacitance. Any material in electrostatic domain can be modeled in terms of capacitance. Its units are farads. Its units are farads. Okay, any material in electrostatic domain can be modeled in terms of capacitance. Its units are what? Farads. Okay. Now graphically, if I show here also, if I show graphically, yes, graphically, like Q equal to CV. Okay, Q equal to CV. So this is like Y equal to mx na sir, and the slope clearly represents capacitance. The slope clearly represents capacitance. Okay, and this I is C dV by dt, and I is C dV by dt. Okay, so there are total 6 forms I told. Another 3 forms I will introduce. Another 3 forms I will introduce when I start frequency domain. There another 3, total 9 forms. So in LTI domain, this is the first form. This is the second form. Resistance is the component modeling the linear time invariant domain. Okay, now then in electromagnetic domain, this is third form, and this is the fourth form. Inductance will model anything in electromagnetic domain. Then in electrostatic domain, this is the fifth form and sixth form. Okay, so this is the Ohm's law for capacitance, and capacitance represents electrostatic property of matter. So that is why you see now this first, third, and fifth odd equations. First, third, and fifth. Okay, this is first, okay, third, and fifth represent field theory equations. Okay, that is Ohm's law in field theory. But however, just this second, this fourth, and sixth represents lumped forms. Okay, electric circuit. So that is why in my subject 3 equations for Ohm's law, sir. So in LTI domain, V equal to IR. In electromagnetic domains, V is LDI by dt. In electrostatic domain, I equal to C dV by dt. So with this only, I will explain everything in circuit theory. Okay, na? So these are the 3 forms of Ohm's law. Okay. So I will stop today here. Anyone can ask doubts. Okay, anyone can ask doubts. I will stop here today. So tomorrow again 7 o'clock. Okay, 7 to 10:30. There will be a break from 8:30 to 9 as usual. Chalo Akshay, what is your doubt?
Sir, in that planar network questions, that second question, that bridge like.
What is your doubt? Tell me.
This one, sir. Here that what happened to that 1 ohm resistor between node 1 and node 3?
Node 1 and node 3. Yeah, forgot. Yes, everybody. That is also there, but it is planar, na? Very good. Correct.
Okay.
Correct.
Okay.
I forgot. Yes, that is also there, but it is still planar, na?
Yes, sir. Yes, sir. Correct.
Yes, very good. Very good. Thank you. Thank you, mister. Your name, I forgot. What is your name?
Akshay, sir.
Akshay. Everybody, please listen. As one student claimed this 1 ohm, I forgot, but it is between node 3 and node 1. I wrote like this also. Or you can write this side itself. But still it is planar. That is my argument. Yes or no?
Yes, sir. Correct, sir. Thank you, sir.
It is planar only. Right. Very good. Anyone else doubt? Anyone else doubt? Pranjali.
Hello, sir.
Yeah, tell me.
Sir, that question in which the branch is coming across short circuit.
Okay, I'm coming there. Tell me, what is your doubt? I understood. Tell me, what is your doubt?
Sir, they're that last node only, sir.
Tell me. See, this last node is neglected because this is not a working part of the network. I know you may say, sir, this is also node, you may say, nah.
Yes, sir. This 4 ohm is remaining because.
Listen. Because there is a short circuit across this passive system, current cannot flow now because there is no potential difference actually.
Yes, sir.
Because there is no potential difference and current cannot flow, these two are not working branches.
Okay.
So this cannot be a working node. So we remove the unnecessary part of a network. Okay, we remove the unnecessary part of the network, and this is the circuit.
Okay, sir.
Okay, now here how many? See this node 1, 2, and this is 3 because it is a single node. Here 1, 2, here 3. Total 3 now. So degree is 3 principal node.
Yes, sir.
Okay, any doubt?
No, sir. Clear.
Okay, good. And Sunil, Sunil, talk. Sunil, talk.
सर सर हो गया सर, वो डाउट आपने पूछा था, 1 and 3 का रजिस्टर
हो गया डाउट क्लियर हो गया.
हो गया सर.
Okay, very good, right. And this Shiva talk.
Sir, good morning, sir.
Tell me.
Sir, the same question, like why can't we connect that 4 ohm in parallel with 3 ohm and we can reduce the circuit? Is it possible?
Simplification is a different process. Simplification is a different process. Our aim is to simplify and make it more simple. That reduction techniques we will start. But as per the definition, these are the number of nodes and branches. See, if you simplify and lump, like here also, I can convert this star to delta and make it more simple.
Yes, sir.
So simplification is a different process. But as far as a given topology, we should not disturb, and that definitions we are learning first.
Okay, sir. Sir, like for calculating the number of nodes and branches, we should keep the circuit as it is.
Until and unless, see, first we are learning these definitions. Later I will also add what simplification techniques. Once we simplify further, then we can again define. But as of now, we are learning first definitions only.
Okay.
Later we will also use reduction techniques and apply further, and more faster and simple solutions will come.
Yes, sir. Sir,
Okay.
If each individual element is considered as a branch, or any element connected between two nodes together is called.
See, actually, branch is an elemental connection between nodes. That means it should be a working element where current flow. Okay, that is the meaning. So working, first of all, yes, branch is an elemental connection between nodes. For example, this looks so simple, but here there is no connection. Now this cannot be a node, so this cannot be a working branch.
Okay, sir.
So branch is an elemental connection between nodes, or working element between nodes. You can write like that.
Okay, sir. Here in like if a resistor is connected in series with 10 ohm, then it is together called as a branch, or like each individual element is called as a branch.
Each individual element is branch. As per definition, each individual element is a branch.
Okay, sir.
I will say this together is a series branch. This 10 and 3 together is a series branch.
Okay, sir. So 10 and 3 alone, like separately, they are branches.
Branches, working elements. Okay.
Okay, sir.
Okay.
Thank you, sir.
Right. Then Haripriya.
Sir, in non-planar network, what is overlap, sir?
Overlap means you cannot represent in a single plane. See here, what is that? See here also this looked C2 looked like overlapping above one above the other. Na?
Yes, sir.
It is looking like overlap between one above the other, but after writing like this, it is planar only.
Okay, sir. But what is the difference between overlap, sir?
But here you see, here this overlap 4 ohms you cannot write on a single plane. You see now, suppose you bend in any way, this 4 ohms cannot come in a single plane. Overlapping means one over the above, one over the above.
Okay, sir.
Understood?
Yes, sir.
Okay, right. Then Sweta.
Hello, sir. In that short circuited branch question only, sir.
Tell me, what is your doubt?
सर यस सर, इसमें ऐसा नहीं हो सकता कि जैसे ये 20 वोल्ट्स वाली ब्रांच से करंट फ्लो हुआ और 1 ओम से फिर शॉर्ट सर्किट में और सीधा 4 ओम में, तो 3 ओम वाली ब्रांच भी कंसीडर करेंगे क्या? मतलब शॉर्ट सर्किट है तो उसी में जाना चाहिए?
नहीं, अगर ये 4 ओम भी नहीं है तो पूरा शॉर्ट सर्किट है तो 3 को बाईपास करेगा, लेकिन ये एक ही नोड होके ये 3 और 4 पैरेलल हो गया ना इधर.
ओके सर.
अगर आपके हिसाब से ये 4 ओम भी नहीं है तो ये शॉर्ट सर्किट है तो पूरा 3 ओम्स बाईपास करके इधर चले जाएगा.
अच्छा, ओके सर.
Actually that 4 ohm is there na. Now this 3 and 4 become parallel.
Okay, sir.
Okay, that is why short circuit completely in parallel to passive element is redundant.
Okay, sir. Got it.
Okay na? Right. Okay, now everybody, I think your doubt. Chalo, very good, sir. Slowly I'm getting very good response. I'm happy with this. Okay, chalo, tomorrow everybody 7 o'clock. Okay, today there was a technical glitch, sir. I need to reinstall this software which really created a problem, sir. Okay, but tomorrow sharp 7 o'clock we will again start. Okay, everybody. Okay, today is a Sunday. Have something to read. Don't waste your time. And tomorrow 7 o'clock again. We'll go very slowly, sir. I'm comfortable like this. Please understand my problem also. I'm an old person, 42 years. I'm struggling. So please cooperate. We will do our best.